Hi, so today I'll be teaching you guys a lesson about transformation of polynomial function. First of all, we need to understand three main types of the parent function when a is bigger than 0, which is positive value. So when it's quadratic, it's f of x equals x power of 2. It will look like a parabolic shape. As you can see, it's upwards. And for cubic, it is f of x equals x power of 3. So it'll look like an S shape. And for quartic, it is f of x equals x power of 4. It is similar to quadratic, but as you can see, it's a bit different from by comparing two different picture. So when it is smaller than 0, when the a value is smaller than 0, which is negative value, there'll be a reflection on the x-axis. So comparing to the previous one, as you can see, it's just upside down. So quadratic, it'll have a negative x power of 2, which is like smiley face but upside down. For a cubic, it's negative x power of 3. So it goes from quadrant 2 to quadrant 4. And for quartic, it is negative x power of 4, which is also just upside down. So general form of polynomial transformation. The original form that we know is y equals af k times x minus d plus c, right? However, in polynomial form, we have this power. So power of 2, power of 3, or power of 4, depending on which which graph we are looking for. This is because parent function for polynomial function is y equals x power of n is just the degree of the polynomial. So like I said, n is the degree of polynomial, which is depending on what graph we're looking at, and y is the stretch or compression by a factor of a. So this a value, and it also includes the c, which is translation up or down, and for x, it's stretch or compression by a factor of 1 over k. This one also includes d unit translation to the left or right, which is this inside one. So in order to find the new point, we need to know the coordinate of p is point xy. We need to memorize this formula, which is x over k plus d, comma a times y plus c. This would give us the new point. So we just plug in the values inside and calculate it. So first example, quadratic. We need to learn how to describe the transformation that will apply to the parent function, to the specific parent function. So for this general form, it'll be y equals a times k, bracket x minus d, power of 2. Remember, this is important, plus c. So example, so this is my example, y equals negative 3.2, bracket x minus 5 power of 2. In order to find the transformation that will apply to this, we need to identify the parent function, which is power of 2 degree. So parent function will be y equals x power of 2. Then next, we need to identify the AKDC values. So this is easy. We have learned this before as well. So A is negative 3.2, K is 1. We can see there's an invisible 1 right here. And D is 5, and C is 0. There's no C value. So from this, we can understand that transformations are reflection on the x-axis, as A is a negative value, and vertical stretch by a factor of 3.2, and horizontal translation 5 units to the right. So this part we also need to memorize from this part that I explained previously. So next is transformation with cubics. So the general form is this. It is the same, however, there's a power of 3 instead of power of 2, just like the previous one. So example, y equals negative 3, bracket 1 over 2, bracket x minus 3, power of 3 minus 5. So in order to identify the parent function, we see this degree right here. It is degree 3, so parent's function will be y equals x power of 3. Identifying the AKDC value. So A is negative 3, K is 1 over 2, D is 3, and C is negative 5. So it is pretty simple and straightforward. We know that there's a reflection on the x-axis, vertical stretch by a factor of 3, horizontal stretch by a factor of 2, horizontal translation 3 units to the right, and last vertical translation 5 units down. So we can see this is for A, this is for K, this is for the D, and this is for C. Next is transformation with quartic, the last one. So the general form is also pretty straightforward. It's the same thing as previous ones. However, the degree is 4 right now. So example, y equals 4 bracket x minus 0 bracket power of 4 plus 2. So the parent function, it is the same thing that in order to identify, we just see the degree is 4, so y equals x power of 4. So in order to identify the AKDC, we need to find A, which is 4, K is 1, like I said, it's invisible right here, and D is 0 right here because there's no value, and, and C is 2. So the transformation is vertical stretch by a factor of 4, K we just ignore because it's just 1, and vertical translation 2 units up, which is C. So next we would learn how to find the equation from a graph. So this is my example right here. We need to learn how to describe the transformation just by looking at the graph given and creating our own equation at the end. So this is the parent function, y equals x power of 3, and this is my graph that after transformation. So in order to find the new DC, we have to use this formula previously mentioned earlier, which is P is 0 and 0, which is this part. So 0 over K plus D, which is 0 plus D, and basically it's D, and for the Y coordinate, it's A bracket 0, which is A times 0, which gives us 0 as well, plus C. So basically it's just D and C. So this point DC is negative 2 and positive 3. So as you can see here. So we plug this into the general form with, like here, as you can see, y equals a bracket k, x plus 2, power of 3 plus 3. This is the general form because parent function is x power of 3. So we have to choose this as degree 3. We need to find the a value right now. While doing that, we assume that k value is 1. So we substitute any point right here. So this will be the easiest one, in my opinion. 0, 0, 0, and 11, this coordinate. So we plug in 0 and 11 into x and y. So x would be 0, y will be 11. So as you can see right here, I put 11 here and put the 0 right here. So we calculate this, isolate for a. So bring the 3 over, which is 11 minus 3, and 0 plus 2 is 2, and 2 times 1 is 2, and 2 power of 3 would be 8. 8 times a is 8a. So this is what we have right now. 11 minus 3 equals 8, equals 8a. And we isolate for a, it'll become 8 divided by 8, which is also 8, which is also 1. So we know the answer that a is 1 right now. So we plug in the a value into the equation that we had. So it'll be y equals 1, which is the a, bracket 1 is also the k, we assume it as 1, and x plus 2 bracket power of 3 plus 3. So to simplify this, it'll become x plus 2 power of 3 plus 3. This is the final equation that we have. So from here, we can find the transformation that will apply to the parent function. it'll be horizontal translation, but 2 units to the left, and vertical translation 3 units up. So as you can see, it is two 2 units to the left, 1 2 right here, and 3 units up, which is 1 2 3, 1 2 3 right here. So as you can see, this graph is correct, and the answer is correct. That's all for the lesson. Thank you.